So now that we know how to solve equations with one variable, let's learn how to solve equations with two variables. In this case, these equations have x's and y's, and when we're solving with two separate variables, we need to have two separate equations that we can manipulate in order to solve for each variable, because we cannot solve for both variables in one equation. It's just not possible. But let me show you how to do it with two. So our first step is we have to solve for one of these variables in terms of the other one. So we just want to get one of these by themselves. Let's go with x, because if we took y away from this side, it would just give us x equals something. And that's what we want. We just want x by itself. And I'll show you why here in a second. But let's just do that. So if we bring this down here, x minus y is equal to 2. And now let's subtract, or let's add a plus y to both sides. Sorry, I wrote that weird. So we're just adding a plus y to both sides, and that'll give us x is equal to 2 plus y. Okay, now that we have our x in terms of y, what we can do is we can take this for x and we can plug it in to our other equation. And once we do that, we'll just have one variable in this equation. What we can't do, we can't plug it back into this equation, because that would give us 0. 0 equals 0, and that would not help us solve for y. But, so if we plug it into this equation, it'll help us solve for y, which will be the only variable left. So how do we do that? Well, let's bring this equation over to x plus 5y is equal to 18. And then we just want to plug in our expression for x that we solved for in the other equation. So 2 times our x here, 2 plus y. Do you see how we did that? We replaced the x with what x is equal to. Okay? And then plus 5y is equal to 18. Let's simplify this. So 2 times 2 is 4. And then 2 times y is plus 2y. And then plus 5y equal to 18. Let's add like terms. We have 4 plus 7y equal to 18. Let's subtract 4 from both sides. So we have 7y is equal to 18 minus 4 gives us 14. And then we want to keep solving for y. Let's divide both sides by 7. So 7 divided by 7 is 1. Y is equal to 14 divided by 7 is 2. So this is our solution for y. And now that we have the solution for y, we can take this and plug it into either equation. But let's just do the first one because it'll be easiest. So let's plug y equals 2 into our first equation. And that gives us x minus our y here is 2 is equal to 2. And then now we can easily solve this for x. So we'll add 2 to both sides. And that gives us x is equal to 2. So our final solution is x is equal to 2 and y is equal to 2. And that is our solution for x and y and our solution for this example. Solving with two separate equations like this is known as solving with a system of equations. So once again, how we did it was we just got one of these variables by themselves, so we could let x equal something or y equal something, and then we took that, so we got x equals this, and we plugged it into our second equation. So wherever x was in our second equation, we took what x was equal to, and we put it there, right? That's what we did here. And then from there, we just simplified, and we were able to easily solve for y. So we solved for y here. And then at that point, we were able to plug what we got for y into either equation. We just did the first because it was easier, and that gave us x was equal to 2. And that is how we got our solutions. In this example, we can solve it using the same exact methods. So let's decide which equation we want to start with to get one of the variables by themselves. Let's do y this time so we can solve for y in terms of x. So let's do that in this equation. So if we subtract x from both sides, that'll give us y equal to 6 minus x. And then at that point, we can plug this into our other equation for y, right? So let's do that. Let's say 3x minus 2y is equal to 7. And then if we plug in our expression for y here, so we have 3x minus 2 times our expression for y, 6 minus x, and then is equal to 7. Now we're going to just simplify, so 3x minus 12 minus 2 times minus x is plus 2x equal to 7. Let's combine like terms, so we have 5x minus 12 is equal to 7. So let's add 12 to both sides now, because we're just solving for x. And that gives us 5x equal to, what's 7 plus 12? 19. And then if we divide both sides by 5 to solve for x, that gives us x is equal to 19 divided by 5. So we have our solution for x now. And what we need to do to get our solution for y is we just plug the value for x back into either of the equations. So we'll probably do the first one, or we'll probably do this one because it'll just be easiest to solve. But let's do that. So x, our value for x is 19 divided by 5 plus y is equal to 6. So let's plug in our x value. So x is 19 divided by 5 plus y is equal to 6. Now, if we subtract 19 divided by 5 from both sides, that gives us y is equal to 6 minus 19 over 5. What's the least common denominator here? It is 5, right? Because 1 times 5 is 5. So if we multiply 6 by 1, or 5 over 5, to get it in terms of the least common denominator, that will give us, we're just simplifying still, that'll get us 30 over 5 minus 19 over 5. So now we can subtract these fractions from each other. So what's 30 minus 19? That is 11. So y is equal to 11 over 5. And that's our solution. And we have our x here. And so we have our solution for x and y. And our solutions for the expression, or for the example, if you ever want to double check to make sure you did the math right, all you need to do is plug in both of these to either equation. And say, if you plugged them into this equation, you would just say your x value, which is 19 over 5, plus your y value, which is 11 over 5, would give you 6. So let's actually just try that. So we're just checking the math here. So if we did our x value, which is 19 over 5, plus our y value, which is 11 over 5, that should give us 30 over 5, which is 6, right? So 19 plus 11 is 30 over 5. What's 30 divided by 5? That is 6. So it does check out, and we did the math correctly in this example. So up until now, we've been solving systems of equations by using a method called substitution. In this example, I'm going to show you a new method, which is known as solving by addition or subtraction. So how we do it is we basically multiply each equation, both sides, until it is something that if we put everything on the same side of the equal sign for both equations, if we set both of these equations as equal to each other, one of the variables, say x or y, would add up to 0. And at that point, we could solve for that other variable that's left. So if you look here, we could easily multiply both of these up to either 12 or negative 12. So let's take the first equation, actually. Let's take the first equation and move everything onto one side. So 6x plus 4y. If you subtract 49 from both sides, 49 is equal to 0. And we want to multiply this to get up to, let's say, positive 12. So what do we need to multiply both sides by in order to get 12y? Well, we need to multiply it by 3. So we're going to multiply both sides by 3. Excuse my messy writing, but with 3 times 6x is 18x, and 3 times 4y is 12y, right? That's what we wanted. And then 3 times negative 49 is negative 147, I think. And then 0 times 3 is 0. So this equation is ready. Now we need to take care of our other equation. So I'm just going to draw a squiggly line here so we know to keep these separate for now. So 4x minus 3x, or 3y, equal to 10. Let's subtract 10 from both sides so we can get everything on the same side of the equal sign. So 4x minus 3y, subtracting 10 from both sides. So you see how that is that still? Now we need to get to positive 12. So what we need to do, how do we get negative 3 to positive 12? Well, we need to multiply it by negative 4. So we need to multiply both sides by negative 4. So negative 4 times that. So negative 4 times 4x is negative 16x. And then we have negative 4 times negative 3y gives us plus 12y, right? Because we can cancel those later. So we did it right. That's what we wanted. Negative 4 times negative 10 gives us plus 40, all equal to 0. Okay, now let me show you something. See how both of our equations are equal to 0? See that? So is 0 equal to 0? Yes, that's a dumb question. 0 is equal to 0. But what that means is both of these equations are equal to each other because they're equal to 0. So what we can do is we can make a new equation that has this equal to that. And what that will do, that will cancel out our 12y, and we can solve for x at that point. So let me write that. We have our first equation, 18x plus 12y minus 147 is equal to 0, which is also equal to our other equation, negative 16x plus 12y plus 40. And now what we can do is we can just simplify this, and we already know these 12y's will cancel if we subtract 12y from each side. And now we're left with 18x minus 147 is equal to minus 16x plus 40. So let's simplify this. Let's add 16x to both sides. So 16x. What's 16 plus 18? I think it is 34. So 34x minus 147 is equal to 0x over here plus 40. Now let's take this 147 to the other side. 147. So 34x is equal to 187. Now, if we divide both sides by 34, that gives us, let me see if that is a clean number. We'll just leave it as an improper fraction for now. But x is equal to 187 divided by 34. And so now what we can do is we can just plug this into either equation, and that will give us we can solve for y at that point. So let's do that over here. Did not leave a ton of room on the board, but let's do this equation because it looks like it will be easier. So I'll just write 4x minus 3y is equal to 10. And I actually checked my calculator. This number is equal to 5.5. So for the sake of not doing messy math in this example, we will just plug in 5.5 to make our lives easier. So if the x is 5.5, we can write this as 4 times 5.5 minus 3y is equal to 10. So 4 times 5.5 is 22. 22 minus 3y equal to 10. Now let's subtract 22 from both sides. Negative 22 and then negative 22. That gives us negative 3y equal to 10 minus 22 is negative 12. Now, if we divide both sides by negative 3, that will give us y by itself is equal to negative 12 divided by negative 3 is positive 4. So look at that. We got a nice clean solution for y. And we have our solution for x. So that is our solution for x and y, and also our solution for this example. Once again, we solved using addition or subtraction, and what we did was we multiplied. Well, first we got everything on one side of the equal sign, and then we multiplied it by something that would cancel out the y's, right? Because the y's were equal to each other. And then because both equations were equal to 0, we set them equal to each other, and then we were able to cancel the y's out. And then at that point, we could solve for x. And then just like in substitution, we took the x value and plugged it into either one of our equations up there. And that gave us the solution for y. So whenever I solve a system of equations, I always want to look at it first and see which method of solving will be easiest. A little cheat I use is if I ever see a variable by itself already, like just an x or say just a y, then I would use substitution because you don't have to divide by anything and you don't have nasty fractions to start out with. So otherwise, I most of the time will use addition or subtraction because that's easiest if it doesn't have, say, just like an x or just a y. So how can we do a addition or subtraction? Well, oh look, we can multiply the y's up to negative 12, that would be easy. So if we do our first equation, what do we need to multiply it by to get, well, first of all, let's just get everything on one side. 5x minus 4y. Subtract 8 from both sides. Minus 8 is equal to 0. And if we multiply this by 3, that will give us 12. So 3 times our both sides. That'll give us 15x, and then minus 12y, and then minus 24, equal to 0 times 3 is 0. And then for our other equation, we can bring it all down here. Let's add 25 to both sides to get everything on the same side of the equal sign. So negative 4x, negative 3y, plus 25, right? Equal to 0. And the reason we brought everything over to the same side of the equal sign, again, is so we can set both these equations equal to each other. But let's multiply both sides by, we need 4. 4. And so 4 times negative 4x is negative 16x. And then we have a 4 times negative 3 gives us negative 12y. And then we have 4 times 25 gives us positive 100, all equal to 0. So we have our two equations here, and we can set them equal to each other. So let's take the first one. We have 15x minus 12y and minus 24 equal to our second equation, minus 16x, and then minus 12y plus 100. Remember, we could only set these equal to each other because they were both equal to 0. Now we see we have a negative 12y on both sides. We can add a 12y to both sides, and that'll cancel all of the y's. So we're left with 15x negative 24 is equal to negative 16x plus 100. We can, let's see, what do we want to do? Let's add 16x to both sides, so we're left with the positive quantity of x. So plus 16x, and then 16x, and that'll give us 16 plus 15x is 31x minus 24, and equals, no x is over here, 100. So now let's add 24 to both sides, and that gives us 31x equal to 124. And now, if we divide both sides by 31, let's see, that's a mess. That gives us x is equal to 124 divided by 31. And then let's check our calculators to see if this is a clean number. Most likely it is not. Oh, it is. This is equal to 4. That's a lot easier to work with than a big fraction. So our x is equal to 4. Now that should be easy to plug into one of our other equations. Which one do you want to do? Let's do, let's pick this first one. This first one looks easier. So 5x negative 4y is equal to 8. And once again, we're just going to plug in our x solution here. So x equals 4 into this. That gives us 5 times 4, right? Minus 4y equal to 8. And we can simplify that. 20 negative 4y equal to 8. So let's move the y to the other side of the equal sign so that, actually no, let's move the 20 to the other side of the equal sign so we can get y by itself. So subtract 20 from both sides, and that gives us just negative 4y. Negative 4y equal to 8 minus 20 is negative 12. And now we can divide both sides by negative 4 to give us just y by itself. So y, negative 4y divided by negative 4 just gives us y. And over here, negative 12 divided by negative 4 gives us positive 3. So there's our solution for y. And we have both our solutions and the solution for the system of equations. If you want to check it, you can just plug them back in. But that is the solution for this example.
Hey guys, if this video has been helpful to you, click the link in the description to get access to the complete Easy STEM Algebra 1 system, which includes a textbook, homework, and all of the course videos in order.